happy note. Let's see. The topic is evaluating learning outcomes and intrinsic motivation, a case study of the Haahr 3D by Alberto Rojas-Salazar.
Nice job.
Okay, hello everybody. So, I will try to go fast. Yeah. So, what is this presentation about? And it's, and as its name says, it's a evaluation of a video game that we created time ago. It is a video game that aims to teach computer science conceptual knowledge, and so the motivation was that well, computer science is difficult. It has a lot of complex concepts and models, and students find them challenging. So the video game tries to make it easy for the students. Well, that is the aim, to make it easier for them to grasp that knowledge. So, well, also academic literature said that some how is this, topics of computer science such as logic, programming, concepts, data structures, and computer architecture are difficult for the students. They have found that students find them very, very difficult to understand sometimes. And there are several factors contributing to these learning difficulties, such as the complexity of the learning activities, misconceptions arising from natural languages, lack of mathematical knowledge, inaccurate mental models, and also inadequate strategies for solving abstract problems. Well, environmental factors, including the student existing knowledge, the way that they did their current mental models, and inefficient instructional approaches. So also constructivism paradigm states that the process of acquiring knowledge and comprehending a new subject required establishing connections with previously acquired knowledge. Therefore, effective learning strategies should consider learning's prior knowledge and facilitate their active involvement to promote the effective integration of knowledge. So, we propose that analogies and digital game-based learning are effective approaches for teaching complex conceptual knowledge in computer science. Specifically, we create a game to teach binary search tree conceptual knowledge. And okay, that is what analogies are. Compares the structures of two domains that share symmetrical relations among their components. So what we are doing is to integrate binary search tree concepts inside the video game. And yeah, digital game-based learning is a flexible and interactive learning approach that can effectively represent and facilitate understanding of abstract and complex knowledge. Let me check. So in this case study, what we did was to conduct an evaluation of an educational video game, and what we are measuring is the learning outcomes and the intrinsic motivation. And we also conduct a comparison between our learning video game and some video tutorials. So the materials that we use were a video game called Haahr 3D, and this the people who were in the experimental group were using this video game, that it is an immersive 3D person adventure PC game created using Unity. Haahr targets bachelor students that have programming courses. It could be like engineering, mathematics students, and computer science students, and so on. So it was well, related to the video game aspects. It is a cyberpunk science fiction game. The player assumes the role of a robotic hacker, and it is guided by a non-character player called Anonymous, and the missions that the player has to complete is to infiltrate and extract information from corporate computational systems that are arranged the same way as data structures. And let's see, and binary search tree concepts are introduced by Anonymous when he explains the challenges and missions of the levels. So those are like the levels. Actually, well, currently the game has 4 levels. The first level, it's just a tutorial of how to play it. The second level, it tackles like a binary tree node concept. The third level is about the binary tree structure. And the fourth level is about a binary search tree of the binary search tree concepts. And well, we have like learning objectives that are listed there. Like there are 8 learning objectives, and learning activities. That there are 13 learning activities. And this is how it looks, the game. I will show like a small demo. So basically, this is like the second chapter. So it looks like this. So they have to complete missions that Anonymous asked. Oh, the music is there. So he explains like the concepts, and he started like and explained how the manuses are linked together. They are linked the same way as a data structure. So the idea is that you can like make connections between the 3D environment of the game and like the nodes of a binary search tree. So this is how it looks. So the second level involves a small, they increase in difficulty, but they are simple. And the idea is that he explained like part of the concepts, and you just start solving like puzzles that that Anonymous asked. And well, actually these 4 games are just like the training of this robot. Like they are calibrating their system. So actually, if I implement the next levels, it will be like real missions. Like these are just like a type of tutorial. Okay, we will return to the slides. Okay. Okay. So for the control group, we use video tutorials that they actually there were we used 2 video tutorials. The first covers like fundamental concept of binary trees, and the second it was focused on binary search, the binary search tree data structure. The data collection tools, we developed our own test, and we calibrated it with like 200 students using Rush model, and we validated it with it was validated by 6 professors from University of Costa Rica and Trinity College, Dublin. And we also used the intrinsic a Spanish translation of the intrinsic motivation inventory. Well, in total, there were like 54 students participated and completed all the surveys and tests. The control group had 28 participants, and the experimental group had 27. And they were randomly assigned to a control or the experimental group. Well, we use an independent repeated measure design. And these are the results, but I think that they look better in these box plots. So, in the pretest, the students were like the control group were here, and the experimental group were here. They were pretty similar, both groups. But after the intervention, both groups increased their knowledge. The experimental group was performed slightly better than the control group. But if we check the difference between the post-test and the pre-test, we see that they are very close to each other. However, it means that they learn very well with the video game also. They increased like four questions, 4 points. But in the other side, well, in the intrinsic motivation scores, they perform much better. The group that played the game. So a lot. So here are like the results of the inferential analysis between groups, and we use t-test and Manwini U-test. And well, the post-test scores, they were like a statistical significant difference. But anyway, as I told you, the most interesting were the difference, and there were not any statistical significant difference there. However, in the intrinsic motivation, there are a lot of difference. They prefer the game, the students who play the game. Okay, discussions, and well, the students who engage with the game experience significant improvements in their learning gains in both groups with the video tutorials and video game. But this indicates that well-designed educational games have the potential to be used as effective, has the potential as effective as video games, tutorials in teaching conceptual knowledge, and the students who play the game exhibit higher levels of intrinsic motivation compared to those who watch the video tutorials. So I think that these games are good tools that we can use as a complement to regular classes, like the traditional classes. I used this game with some of my students in programming 1, the first course of programming, and they enjoyed a lot to play the game because it's like something different that they don't often do during classes. Limitations of this experiment is the sample size is just 64 students, so we need a bigger sample, a larger sample if we want to get like better results, like more conclusive results. And also, we assume that the Spanish translation of the intrinsic motivation inventory possesses the equivalent psychometric properties as the original version. That is a small limitation also. So, questions?
Okay, thanks. Any questions with a bit of time?
There are 2 questions.
I have a question. I really like the game, so I feel like if I were using that game for my data structure, of course, I would be much better.
Yes, seriously.
And so interesting, and it's so cool that you actually find a way to, because the context is so relevant, you know, it's hacker and it's robot in a robotic base sort of thing, and it's about data structure and biometry and that research really it's very valuable.
Thank you.
Okay, I think there was another question, yes?
The game looks amazing, thank you. So my question is, what's your plan for distributing the game? Do you have any kind of plan?
Oh, right now I don't have any plan.
Because I like to play it too.
I would like to develop more levels right now because I did some interviews with students who play the game. the interviews were weird, actually. Yes, they were saying like, oh, okay, I want to shoot something, for example. Or another person told me like, the place feel like very lonely, like there is no other robots there, there are no other characters, I need like more people there. I feel like a little bit sad in that place. And they're like, really? And he told me yes, and I was like, okay, that is. So I think that it needs to be polished a little bit more. But yeah, also I will need to port it again because it's made in Unity 18, 19, so and that right now it's Unity, I don't know what version it is right now. Probably it will not run again. I will have to rewrite the code that the whole thing. So yeah.
Okay, I think that concludes the afternoon session. And yeah, thanks again for your presentation. And I believe some closing words from Max.